right? So UART stands for Universal Asynchronous Receiver Transmitter. Why actually this is required? So already I think I have told you this. This is microcontroller or your computer. So this is LPC 2148. I'll write at the top or here LPC 2148 microcontroller. This has two UARTs. Okay. It has many other peripheral devices also. This is okay. UART 0. This is UART 0 and this is UART 1. Okay. And I think I have told you this. Why? I mean, other peripheral devices are also here. Which are the other peripheral devices present here? Memory controller will be there, interrupt controller will be there, ADCs will be there, DACs will be there, Ethernets are there, timers and counters are there. Okay. So, and then we have interrupt controller, and then addition to that, we have main part component is RF processor, CPU. This is CPU, okay, and all other are peripheral devices, okay. So we have discussed almost all the things now. We have come to UART, UART interfacing. Other interfacings we have discussed as per your syllabus, right? So now this microcontroller has two UARTs here, UART 0 and UART 1, okay. So this is your computer, I mean embedded system. Whenever user enters the data through USB, universal serial bus. Okay, so the data will be entered in a serial fashion like this, one bit after the other. So first one enters, then one enters, then one enters, zero enters. Okay, board is visible, no? Okay, so then one and zero enters, one enters. So one after the other, serial fashion. So it is not that all group of bits will enter together, okay, or parallelly to a computer. They will not enter together or parallelly to a computer. Okay, so one after the other, one after the other, in a serial fashion, data will enter to the computer. But the data bus of the computer within this, right? So we have parallel data bus. We have depending on the configuration of the computer. So this data bus can change its size. So in some microprocessors, it is 8-bit processor, 16-bit processor. Okay, but your ARM processor is 32-bit data bus. Okay, so this is 32-bit data bus. I have not written all the lines here. The size of this is 32-bit, and you know that on all the registers of ARM processor is also 32-bit because everything should be compatible. Okay, so now this is a 32-bit data bus will be there, and this bus will be running from microprocessor to several peripheral devices. I mean, from peripheral devices to microprocessor, and also from IO port to microprocessor. Okay, so this data bus will be carrying the data, right? So from various parts of this computer or various parts of this microcontroller. So and we know that this is parallel in fashion. I mean at a time, so 32 bits of data will be communicated or transferred from one part of the computer to other part of the computer. So hence we say that it is a 32-bit microprocessor or a microcontroller. Okay. So now, but the data enters to the computer. It is in a serial fashion. Okay. So one after the other it enters. There should be somebody to receive this. Okay, serial data, and that should be converted, okay, to a size of the data compatible with the size of the data bus. Okay, data bus is 32-bit. Okay, but the data entered is serial fashion, but data bus is parallel, right? So to convert the serial data into parallel data compatible with the size of the data bus of a computer, so this UART is used. So this UART has two parts. Okay, so what is that? So here it has receiver part and here it has transmitter part. Okay, UART has two blocks here. One is a receiver block, other one is transmitter block. Similarly, here also this has receiver block and this has transmitter block. Okay, so then what happens in this receiver block? So data receives, this UART receives the data in a serial fashion, and within this receiver, okay, so I'll just write a receiver separately. So this receiver has some set of registers are there in FIFO. Okay, so data will be received in a serial fashion. This is a register. Okay, this is a set of, this receiver has set of receiver buffer register RBR. I hope you understood. Receiver buffer register. There will not be a single receiver buffer register here. There will be group of Okay, receiver buffer registers will be there. So, I mean, it will be storing the data in one register. Next data will come. A 32-bit data will be stored in the next, register. Okay, so and it will divide. Okay, there will be, say for example, there are 144 bits serially enters the computer. So then it divides. Okay, 32-bit data. Okay, as one packet. Okay, next 32-bit data as another packet. Next 32-bit data. So it divides like this. Okay, so this 32-bit, right? So next 32-bit, next 32-bit like that. So this first 32-bit data, it will store it in first RBR0 register. Okay, so this RBR0 register will store the first packet. I hope you are understanding. And then there is another RBR1, RBR2 like that. Probably I think there are 60 buffer registers are there. You know what is buffer, no? See, whenever we go to a hospital or any bank, or so there is a queue, like we stand, right? So in a waiting room. Right. So then till the, persons are cleared there. Okay. Till the place is vacant. So then we will be waiting in buffer space and then we will enter. So here also, so data is complete. This database is full. Okay. It is not ready to receive other data. So till the database is empty. Okay. So the data received from the Uart will be placed in the buffer registers. Okay. So as soon as the database is empty, okay, the first buffer register data will go and sit on the database. Okay. So now anyway, it is 32-bit. Okay, so this is 32-bit. Okay, next 32-bit, next 32-bit. Okay, so this 32-bit will go and sit on the database. So directly buffer register will not send the data. Actually, what it does is, as soon as it receives the data, it forms a 32-bit data. Okay, it forms a 32-bit data. How actually 32-bit data is formed? Okay, so I hope you understood. As soon as a Uart receives the data, it comes to the receiver block. What receiver block has? Receiver block has set of receiver buffer registers are there. Okay, some 16 buffer registers are there. So it will arrange first 32 bits, okay, of serial data and places it in the first register. Next 32-bit data will be placed in next register. So like that, it keeps on placing. Okay, so the group of 32 bits data into different registers. Later, okay, so this data will go to the data bus. All right. So after entering to transmitter, because this is a transmitter block, directly receiver will not send the data packet to the data bus. Okay, so it will send the data packet one by one to transmitter. So this transmitter block has one register which is called as THR, transmitter hold register. Okay, so this packet from this receiver block will be received by this transmitter hold register. Then it holds it for certain time. Okay, till this, the data bus is empty. Okay, so then after holding it for certain interval of time, okay, this will be placed onto the data bus. Follow this? Okay, so hence we have transmitter block here, and this is a receiver block. As soon as the data enters the computer, through a serial bus, it will go to the receiver buffer registers of receiver block. Okay, so then it keeps on storing all the data entered. Okay, group of 32 bits. Okay, in a register, because all the registers are 32-bit size. Then while transmitting, okay, so it will send each packet, okay, to transmitter hold register of transmitter block. Then whenever the bus is empty, okay, so then this transmitter will send the 32-bit data frame, okay, fitted into this data bus. Okay, so then internally, because you will be sending this data to get processed. Okay, you have some aim, right? So you will be displaying some message on the monitor, or you will be displaying this message over internet. Okay, right? So it may go to internet, okay, different computers across the globe at different points, or it may be on the monitor of this own system itself. Okay, so hence you will be transmitting some message. Okay, this packet will be in the form of a message, let us say. Okay, so now again, after processing the data in whatever the manner the user wants, okay, later it should go out of the computer. So within the computer, data will be processed in parallel form only. Okay, so it goes to a different block, or it goes to a processor. Then within the processor, it gets processed according to your own task. So if after all the task is over, so now it is, the job of user is to display like the result, okay, on the monitor, or to send the result, okay, to different destinations, right, over the internet, let us say. Okay, so if that is to be done, right, once again, this parallel data goes to this second Uart. Okay, so this UART receives parallel data after processing of the result, okay, through via the data bus, receives it, again places it in, okay, receiver buffer register. Again, it sends one by one packet to transmitter hold register, which is present within this. And then later, it converts this parallel data into serial data. Okay, then, okay, bit by bit will be released to the transmitting channel or communication channel. Okay, you know communication channel, no? So you heard about because you have studied in network and all. Okay, so that is it connects one source and destination. So this is your source computer. This is your destination computer. So in between we have a channel or a media. Okay, so that media may be wireless or it may be wired. Okay, so then your packet is released to the media. Okay, right? Then it may go to satellite or it may go to antenna or whatever. Okay, it will be released to the air. Okay, so then some towers will be there, they will receive the information and then they will be transmitting to the destination. But anyway, here the packets, I mean bits will be transferred in serial fashion only over the channel. Okay, it is not that they will be transmitting in 30 group of 32 lines like this. I think all of you know that. So it will be transmitting in the form of stream of bits only. Okay, so hence we need to convert this parallel data which is processed within the computer into serial data when it goes out of the computer. So that task is also being done by this UART. So UART, that is why it is called as universal asynchronous, okay, receiver as well as transmitter. It receives that serial data, converts that into parallel data compatible or matching with the data bus of a computer, and then after completing the process, whatever user needs, okay, the result should be announced or it should be released to, the media, the channel. Okay, so then once again, this parallel data should be converted into serial fashion like this. Okay, so this is the job of this UART. Did you follow? Did you follow the what is the background concept of UART? Yes. What is the purpose of UART? Did you understand? Please tell me yes or no. All are sleeping. Any doubt here? Okay, so then we will, I told you, no, the packet is received by this receiver block and this is converted into a frame, 32-bit frame. Okay, that is placed into a receiver buffer register. So now let us see, there is a format. Okay, how actually each frame is formed. Okay, each frame is formed in the form of a packet. Okay, in that packet form only data is released out of the computer to the media or channel. I think you have studied that in data communication or networks. Okay, anyway, like even if you don't study also, this is how what is happening. Okay, so now let me see what is the format of data frame. Now data frame has, actually it's a 32-bit length because it should be compatible with, I will not be writing all the 32 bits here. So let me write only the bits which are having some meaning here. Okay. Okay, let me write, this is D0, D1, D2, and then actual data. This is actual data part. This is actual data, and this may be stop bit, start bit. Okay, right? So this is, the first two will be stop bits. Yeah, cannot see?
Ma'am, it is not visible, ma'am.
Not visible.
Some light reflection.
Oh, shall I
It
switch
is
off?
visible, ma'am, but it is some light.
Reflection is there, glaring.
Yes, ma'am.
Can see now?
Yes, ma'am.
Okay. I was telling these two bits are stop bits. And this is parity. Okay. And here you see, here length of the data starts. This length, no, it will have meaning of the information or this carries the actual meaning of the data message, right? So the length of this may be 5 bits, or it is 6 bits, or it is 7 bits, or it is 8 bits. Okay, because anyway it is 32-bit length, no? Okay, so this actual data length can extend from minimum of 5 bits, or it can be 6 bits, or it can be 7 bits, or it can be 8 bits. After this length of the actual data, we have start bit. Okay, that means to say each information or each packet of data is attached with, okay, all this one start bit, two stop bits, and one parity bit, and then remaining bits will be carrying meaningful information. So very valid information is present in this part of the data. Okay, and all other bits could be 0 up to 31, right? So 0 to 31, no, whichever the bits that are not being used here, they are all appended with zeros here. So this is how data frame of, okay, so receiver buffer register will have this format. I hope you are following this. So 2 bits will be for stop bits to indicate when actually packet ends, because this is not the only packet that is being released to the a channel. So packet after packet will be released to the channel. So it is stream of bits. Okay. So this has the message SSIT. Okay. CSE, SSIT. This is another packet. Medical electronics. Okay, so like this. This is one packet, this is another packet, this is another packet. So each character, right? So this is carrying ASCII code. Okay, ASCII code will be represented in the form of zeros and ones. So that will be placed in this part of, okay, this may be 5 bits, or it will take 6 bits, or it may be 7 or 8, like that. Okay, so this may be carrying SSIT, the meaning of this. Right. So this SSIT information is present only in this part of the data. It is not present anywhere else among all the 32 bits. Understood? Okay, the main very meaningful information is present in this actual data part of the entire packet. Okay, so now this SSIT gets released. Okay, so now this is getting processed, right? So and then it will go to, what, UART1. UART1 will receive the information. Again, packet is formed. It will send out, okay, via the transmitter to the channel or to the monitor. So even if you want to print all this on the monitor also, see, whenever you are writing a program, no, you have done so many programming languages, right? Those are there you have done, okay. So print something, okay, printf, right? So enter the values, whatever you are writing, no, so any message that you are displaying on the monitor, I hope you have done, no, message displaying. In a computer, you have done message displaying and all through programmings, right?
Yes, ma'am.
That message displaying, no, so far whatever you have done, it will definitely always goes via UART only. Every computer must have internally UARTs, right? So that UART responsibility is to receive the data. Okay, sometimes if you enter the data through program, it is all right. Okay, understood. If you enter the data through program, so like that we are entering, like, okay, assembly programming and all we have done. So okay, we have entered the program, and interfacing also. We have done, like, we are sending the data right to the ports, or we are entering the data in the memory, that and all, it's all right. But whenever you are entering the data through serial bus, okay, UART receives the data and converts that into a packet like this fashion, and then processes and then displays it on the monitor, or that will be sent or released to the media to send over the internet. Okay, but UART is a must in every computer to do this, to accomplish this task. Understood. So now let us see. I told you this is the data format. Okay, how you understood the data format? So the data format has two stop bits. Okay, sometimes it may be one also. It is not that always it will have two stop bits, but anyway, one stop bit will be there. So parity bit will be there to indicate, okay, the data packet has even parity or odd parity. Okay, so and actual data length. So the data length might extend from 5 bits, 6 bits, 7 bits, or 8 bits. So then it will have, okay, start bit also. The packet starts with this. Okay, now packet begins. Now packet ends. Right, in between you are other informations here. Okay, so this is how every data frame is being formed by UART0. Okay, or any UART. Okay, so this packet of 32-bit length is placed in receiver buffer register, RBR. Okay, so this is a 32-bit length register. So okay, this is the actual meaning. Some bits of this we will have this. Okay, other higher bits, okay, doesn't have any meaning. Okay, this is a data packet. So now this is placed onto THR, transmitter hold register. Then it will go to data bus of the microprocessor, then processes it through processor. Okay, so then again it goes out, okay, to the external world, okay, or to the, I mean, external world only. Okay, out of this microcontroller via another UART1. Okay, so now I think I have explained you the data frame format of, okay, so this UART buffer register. Did you follow this? UART buffer register format, data frame format. How actually data frame is, described like this. Okay, so I hope you have followed this description of data frame. Description of data frame. Did you follow? Hmm?
Yes, ma'am.
Then we have one more term which is called as a baud rate. I hope all of you know what is baud rate. All of you know what is baud rate. See, you are entering the data in the form of zeros and ones to you, computer. So UART receives it and UART transmits it. Receives it, processes and transmits. Correct? So, data is entering from outside world to the computer and processes it and goes out, okay, of the microcontroller to the external world. So this is also external world. Okay, this is also external world. Right. So why are we entering this data? We need the computer to process. Okay. So computer does everything. Okay, produce, the pattern, the way you want it is processed and data goes out of the computer to the external world, the manner in which you want, user wants. Okay, so now the rate at which the bits are received, the rate at which the bits are received one after the other. So zeros and ones are there, one enters, zero enters, again one enters, zero enters. So this is the rate at which the data enters to the computer and the rate at which the data leaves out of the computer. Okay, is called as a baud rate. Or in communication system also, you can you can mention it as the rate at which the data gets transmitted. Okay, from source to destination. It is received and transmitted. The packet is received and transmitted. Packet is received and transmitted. So that we call it as baud rate. Okay, right. So then who fixes this baud rate? What are the factors on which baud rate is fixed? Right. So there are several factors on which baud rate is fixed. So that depends on always the clock frequency, etc. So now we have certain set of registers which explains how actually baud rate should be fixed. And also there is one register, very important register in UART, which is called as line control register, LCR. Okay, so this LCR is a line control register. Right. So if we, it's a 32-bit register. Okay, so if you look at the format of this LCR register has almost all the information, a very important information that is required by UART. What information this has? So I was telling you about, okay, so this actual data length should be 5 bits. Then who decides? Okay, so this LCR will decide, okay, what should be the actual data length of the data frame. Okay, and this LCR itself will decide whether stop bit is 1 bit or, okay, 2 bits or 1 bit. So this LCR itself will decide whether parity should be enabled or disabled. Okay, so this LCR itself will decide whether there is a THR register. Okay, so this THR register, to access this register also, this only should give permission. Okay, so there is 1 bit in LCR register. If it is equal to 0, then only this, transmitter hold register can be accessed. Otherwise, you cannot access transmitter hold register. Understood? Okay, so to access this transmitter hold register also, LCR has to control that. Okay, so to fix the number of stop bits also, LCR will control. To enable or disable the parity bit also, LCR will control. To fix what should be the length of the information, actual data length, whether it should be 5 bits, 6 bits, 7 bits or 8 bits, this LCR will control. Okay, so almost all the operations are controlled, okay, by the bit pattern of this LCR register. Okay, now we should see what is this LCR register and what information we have in this LCR register. Okay, so now we shall see once again, you don't worry, though it is a 32-bit register. So there also we have only 8 meaningful bits. Okay, that describes, right, what all the control that LCR is having. Okay, so now I will be writing the register format of LCR. So D0 to D8 actually is 32-bit register. D0, D1, D2, D3, D4, D5, D6, D7, D8. Okay, so till it extends to D31, put dot here. So D0 to D31 is there. Okay, so now, so let me see what is D0. So D0 and D1 will give us the information like, so these 2 bits are there, no? 2 bits are there, right? Then it will have 4 combinations. So D0, D1 are 2 bits, it will have 4 combinations. 0, 0, 0, 1, 1, 0, 1, 1. Following? Is it visible?
Yes, ma'am.
Okay, if it is 0, 0, then the length of the actual data, I told you the actual data length, no previous, format. Okay, if it is 0, 0, length of the actual data size will be 5 bits. Okay, so if it is 0, 1, the length of the actual data size is 6 bits. Okay, if it is 1, 0, actual data length is 7 bits. If it is 1, 1, actual data length is 8 bits. Because there we wrote simply the data length varies from 5 to 8 bits, that's all. Okay, but here this line control is this LCR. Okay, see this line control register will give the more information. Okay, so if it is 0, 0, then it decides, it controls. Okay, what should be the length of the actual data is controlled by the bit pattern of D0 and D1. If it is 0, 0, then it is 5 bits. If it is 0, 1, then it is 6 bits. If it is 1, 0, then actual data size will be 7 bits. If it is 1, 1, actual data size will be 8 bits. Did you understand?
Yes, ma'am.
Okay, then let us come to D2. So enabling the parity bit. There we have parity bit, no? Okay, so simply we told that particular bit is representing a parity bit. Okay, then who controls whether it should be enabled or disabled? Okay, so if this is equal to 0, if this is equal to 0, parity is disabled. Parity disabled. Okay, so if this is equal to 1, parity is enabled. Okay, so depending on this bit, right? So parity will be enabled or disabled in data packet. So already we generated a data packet and we know like what all should be there in data packet. So data packet has a parity bit. To enable that parity bit, okay, so control is here. So if this is equal to 0, parity bit in the data packet will be enabled. If this is equal to disabled, if this is equal to 1, it is enabled. If this is equal to 0, it is disabled. Okay, this bit is for parity enabling and disabling. So anyway, this LCR register will be controlling enabling or disabling of the parity bit in data packet. Okay, so then coming to this D3. So what is this D3? Sorry. So D2 is for, one second. This comes next. D2 is for stop bit. Okay. So if it is equal to, if D2 is equal to 0, there will be one stop bit. Okay. If this is equal to 1, then there it will be 2 stop bits because we are seeing in data frame. So stop bits can be 1 or 2. Who controls that? LCR register. Okay, if this bit is going to be 0, right, there will be only one stop bit. If this bit is going to be equal to 1, there will be two stop bits. Follow this. Then D3 will be for parity. Okay, so if this is 0, parity enabled. Okay, if this is equal to 1, parity disabled. Okay, so now coming to D4 and D5. So combination of D4 and D5 will be disabling, will be enabling whether it is even parity or odd parity. Okay, so simply we told parity bit will be there or not. Okay, so then comes a question whether packet has a even number of ones or odd number of ones. Once again, that is described by these two bits. Okay, so now D4 and D5 will be having, because there are two bits, no? There will be four combinations. What are four combinations? So first combination is 0, 0. If it is 0, 0, what? If it is 1, 0, 1, what? 1, 0, 1, 1. Okay. So if it is 0, 0, okay, then it is for even parity. Okay. If it is 0, 1, odd parity. If it is 1, 0, forced 0. Okay. If it is 1, 1, forced 1 parity. Because sometimes automatically this should be set to even parity and odd parity. Sometimes it may not happen. So then it should be forced to be at 0 parity, and sometimes it should be forced to be forcibly, it should be set at 0, and forcibly it should be set at 1. Okay, so that is why it is called as forced 0 parity and forced 1 parity. That is also being controlled by these two bits of LCR register. So if it is 0, 0, then automatically we can say that it is even parity. If it is 0, 1, odd parity. Okay, so if it is 1, 0, forcibly, then parity bit is set. Okay, so forced 0 parity and forced 1 parity. Then come to this D6. Right. So what is this? D6. D6 is a transmission control bit. Okay, so what happens here? So if this is equal to 0, what happens? If this is equal to 1, what happens? So if this is equal to 0, right, you cannot transmit the packet at all. Okay, because of some reasons, no. Okay, sometimes there is a line problem, communication line problem will be there. So even if you release the packet also, packet will not reach the destination. At that time, okay, so packet will be held. Okay, it is not transmitted. So if you want to control that, okay, data should not be transmitted now. There is some problem. There is some fault in the line. Okay, so at that time, you are not supposed to transmit the packet at all. That can be controlled by using D6 bit of LCR register. If D6 bit is equal to 0, no transmission of packet. Okay. If it is equal to 1, okay, transmission is possible. See how systematically computer does everything. Okay, right? So only you are receiving and sending the data over your WhatsApp and internet so effectively without any problem. Okay, so because everything is taken care of, okay, by the system so systematically without any problem. Okay, so D6 is transmission bit. If it is equal to 0, what happens? Packet cannot be transmitted at all. If it is equal to 1, okay, transmission is possible. Did you understand? What's the purpose of D6 bit? Did you understand? Yes
Yes.
or no? Hmm? Then come to D7. What is this? D7. Okay. So I told you there is a register which we call it as THR, transmission hold register. So if you want to access this transmission hold register, then this D7 bit has to be equal to 0. So let me write. Okay, because it is a single bit, either it can be 0 or 1. If it is 0, what happens? THR register can be accessed. Okay, if it is equal to 1, if it is equal to 1, there is another register, still I have not discussed it, DLM and DLL register. Okay, so if it is 0, you can access transmission hold register present in UART, right? So if it is equal to 1, transmission hold register cannot be accessed. So if it is equal to 0, you can access, I mean processor can access this transmission hold register. If it is equal to 1, then there are other two registers are there. The contents of these two registers, I mean D stands for divisor latch, D stands for divisor, L stands for latch, okay, most significant bit, okay, and divisor latch, okay, least significant bit, okay. So what is the purpose of the contents of these two registers? I told you about baud rate, right? Okay, there is an equation for baud rate. Okay, in that equation you get these values, right? So you have to have certain values in DLM and DLL so that suitable baud rate can be generated. Okay, so to access the contents of this register, okay, then D7 bit should be equal to 1. So did you understand? If D7 bit is equal to 0, THR register can be accessed. If D7 bit is equal to 1, what can be accessed? Divisor latch registers can be accessed. What is the purpose of divisor latch registers? So the contents of these registers are used to fix, okay, right? So for generating the baud rate. What is baud rate? At what rate the data should be received and transmitted. Okay, so that is very, very, very important here in a communication system. Baud rate is very important. At what rate the bit should be received and transmitted, or number of bits received and transmitted per second, right? So that depends on the bandwidth also. All of us know. Okay, so to access that register which is going to fix, okay, so the baud rate, right? So that can be accessed only if this bit is equal to 1. That register can be accessed. If it is equal to 0, transmission hold register can be accessed. Okay, so rest all the bits from D8 to D31, okay, they are not in use. LCR register D8 to D31 bits, they are not in use. Only we are having the meaning of D0 to D7. So I'll repeat. Okay, D0 to D0 and D1 bits of LCR register will be controlling what? The length of the actual data. If it is equal to 00, then length of the actual data is 5 bits. Okay, if it is equal to 01, the length is 6. If it is 10, then length of the bits is 7. If it is 11, the length of the actual data in the packet. Okay, so it will be 8 bits. I hope you understood this. Come to D2. D2 is going to fix whether the packet should have a single stop bit or it should have two stop bits. If this is equal to 0, then the packet will have single stop bit. If this is equal to 1, okay, then the packet will have two stop bits. Okay, then coming to D3, this is going to enable or disable the parity bit. If this is equal to 0, parity is enabled. If this is equal to 1, parity, if this is 1, parity is enabled. Okay, this is 0 for disabling. Okay, just you reverse. Okay, 0 for disabling and 1 for enabling. And then coming to D4 and D5, right, whether this will describe whether the parity is even or odd. If it is 0, 0, then it is even parity. If it is 0, 1, then it is odd parity. If it is 1, 0, then it is forced 0. If it is 1, 1, then it is forced odd. Okay, so then coming to D6. Okay, D6 will decide whether you can control the transmission of data or not. If this is equal to 0, no transmission of data will be there. Okay. If this is equal to 1, transmission of data is possible. Packet is possible. Then coming to, I was telling, oh, D6 is that. D7. Okay. What is the meaning of, purpose of this D7 bit? If this is equal to 0, you can access, okay, THR register. If this is equal to 1, then you can access DLM and DLL register. Okay. What does this DLM and DLL contains? Contents of this register will be deciding what should be the baud rate. Followed? Right? So I hope you have followed this description, LCR register.
Yes, ma'am.
Okay, now I'll just give the equation of baud rate. Because to write the program of Uart, baud rate is very, very important. So baud rate is given by you have studied in data communication, all of you, baud rate and all. Hmm? The numerator we have PCLK, peripheral clock. Okay, that is 16 multiplied by 256 U0 DLM, divisor latch most significant part, plus U0 DLL. Okay, uh, close the square bracket. This whole thing multiplied by, we have 1 plus div add value divided by mul value. Okay, so where PCLK is peripheral clock. Okay, so then U0 DLM, just now I told you, there is a register which is called as divisor latch most significant bit, UART. U0 stands for UART 0. Okay, so UART 0 DLM register content, and UART 0, I mean register content, DLL, I mean divisor latch least significant bit, okay, of UART 0. Okay, there is a value, divide value and null value is there. Okay, so divide value should be equal to 50. Usually it will be equal to 50, and null value either it can be 0 or it can be 1. Okay, so don't too much worry about this. Divide add value should be equal to 50, normally standard values, and null value should be equal to either 0 or 1. Okay, right. So and then 1 plus something you will get, and this value we have to need to calculate. And then 256, 8 bits will be used. Right. So and then you will be getting baud rate. Usually baud rate will be around 9,600 bits per second. Right. So this is how we need to calculate the baud rate by using the contents of, okay, divisor latch most significant bit and divisor latch least significant content. Right. So I think by knowing this equation, okay, so only one part is left out now, that is programming of UART. Right. So today we cannot complete the programming of UART. So one more class I need tomorrow. So that to complete the programming of UART. Okay, how to generate this baud rate and all equation. Only this part is there, and one simple UART programming. Okay. So I hope you have understood about all these things. THR register, transmitter hold register, it is present in transmission block. Okay, so what will happen to transmission hold register? Receiver buffer register contents will come to transmission hold register. Then later it will be sent to the data bus of the processor or microcontroller. Then once again after processing, this parallel data is converted into serial data by using UART1. Okay, so once again it goes to receiver buffer register of UART1, and then it will go to transmission node register of UART1, then it goes out of the microcontroller to the external world, either to the channel or any monitor display units. Okay, so then you can see the result. I mean, data is being transmitted according to the manner the user wants. Okay, so now to calculate the rate at which the data should be transmitted and received, the baud rate should be calculated. So, to calculate the baud rate, okay, so we need to know the contents of this U0 DLM and U0 DLL. Okay, so these values, of course, these are almost fixed. This is about 50, and this will be either 0 or 1. Okay, so then PCLK will be given. What's the rate, when clock frequency of the system? Okay, generally, what's the clock frequency? Okay, so then that will be given. So depending on that, you need to calculate the baud rate. Okay, so tomorrow we shall discuss 1 or 2 programs on UART and wind up. Okay, is it all right? And in the programs, no interfacing programs also for the internals. So we have discussed how many programs? LED, we have LED blinking. Okay. And then ring, then Johnson. Okay, this is first interface. Second interface is to display, 7 segment display 0 to 9. This is 7 segment display. So either you will be asked to display from 0 to 9 or from 9 to 0. Correct? So or both you may be asked in the internals. Okay. So here also blinking of LEDs, no? Right. So we discussed the examples of blinking LEDs connecting to which pins? 16 to 23, correct? 16 to 23, correct? Correct? Yes or no? Answer fast.
Yes, ma'am.
Sometimes
16 to 23.
16 to 23. Suppose there can be a question. Write a program to blink the LED connected to only P0.0. Understood the problem statement? The question may be, okay, instead of set of 8 LEDs, okay, to blink set of 8 LEDs, you may be asked set of only 2 LEDs to blink, okay, for certain interval of time, okay, and certain interval of time LEDs will be off. So instead of 8 LEDs, you may be asked only 2 LEDs. So you can answer no.
Yes, ma'am.
That is how questions may be twisted. You should be careful, understand the program. So either you may be blinking the LED connected to a particular pin. Say, I may ask you to blink the LED connected to pin number 4 of port 0, P0.4. Okay, only one LED, only one LED. So if that is the case, you have to place a suitable data there, connect only one LED, you have to write the interfacing diagram also. Okay, P0.0 should be connected. You have to indicate that is connected to only one LED. Okay, right. And then you have to write a program. So there will be modifications in the questions to blink the LED also. You may be asked 8 LEDs or 4 LEDs or 2 LEDs or 1 LED. Okay, so you change the data suitably in a register. Okay, IO pin register. Okay, so and then CLR or SCT register, no problem. So then Ring and Johnson counter. Okay, so how many LEDs were there to blink? To have a ring counter, 8 LEDs were there. So you can have 4 LEDs also. No problem. Anyway, be prepared. Okay, so it can be 8 LEDs. Change the loop. Okay, so we put 8 in the loop, no? Less than 8. Okay, so whatever the number of LEDs are given, you put that number in a loop. Okay, so and then Johnson counter also is saying, and 0 to 9, 7 segment display. Okay, so this can be, the question can be either you will be asked to display from 0 to 9, or you will be asked to display from only 9 to 0, or a program can have both 0 to 9 and 9 to 0. Okay, so which is the other one we discussed? Stepper motor. Okay, what did we do here? We rotated the motor for how many steps were there? 50 steps or 50 rotations?
50, ma'am.
Okay, so that value might change. Okay, right? So you see the question, right? So you change the things accordingly in the program, or it may be only anti-clockwise, or it may be only clockwise. Okay, so the program may be asked only to rotate the motor in clockwise direction, or separately anti-clockwise direction, or both. Okay, so you write a program in a diagram also you must write. Okay, microcontroller. Oh, actually you're interfacing a stepper motor. How data passes to stepper motor, and then how do you initialize everything? All those things you need to write. Okay, then fourth one we discussed about DAG. So in DAG we discussed 3 different cases. One is square, other one is triangular, other one is sine. Okay, so in a square wave, okay, so that is positive off and negative off. You send data. Okay, logic 1 for certain interval of time, logic 0s for certain interval of time. In triangular, okay, so you have 2 things like this, right? Suppose in the program, if I ask you to generate only this part, how will you do? Can you do no? Another loop is not included there. That's all. Positive going 0 to FF, one loop is there. No, till it is not equal to FF, you will be incrementing the values. Correct? Okay, suppose if I ask you to only generate a positive going RAM, write a program to generate only positive going RAM. So you can write no, or it may be negative going RAM, or it can be completely triangular waveform. Okay, so that you can do it. Okay, modifications in the program you should carefully note down. And then sine wave. So there are two parts here. Okay, positive off and negative off. Suppose if I ask you to write the program and interface. Okay, so to generate only positive going, how will you do this? Yesterday we discussed no, how many values you will have only to generate positive off if you take at the rate of 7.2?
25, ma'am.
Correct. So in the lookup table, you will have 50 values or 25 values.
If we take both the way, positive and negative, it will be 50, ma'am.
50.
If it is
Okay.
only positive, it is 25.
25. So if you take from 0 to pi or 0 to 180 degrees, right? So there will be only 25 values. So till you reach 180 degrees, whatever the values that you are getting, you put it in the lookup table and proceed. So count value should be equal to 25 instead of 50. Got it? So if they ask you to, to generate only negative half cycle, you see after 180.7, 187.2. Okay, this will become the first value, correct? For negative half cycle. So first value of negative half cycle will be 187.2. Do you accept?
From 180, it will start now.
No, 180 is over. We have stopped at this point. Next point, yeah, 180 also you can start, correct? Okay, so 180 it will start. Okay, next point will be 187.2. Okay, next point in negative half cycle. Next point will be 194 point, how much?
4.
4, something like that. Okay, so you just increment this value at the rate of 7.2 degrees till it reaches how much? 360 degrees. Then you stop. So you'll be getting another 25 values and 25 hexadecimal values. You place that in lookup table and then just only 2 or 3 lines are there. Then you can proceed. Correct? So why I'm telling you is because any changes can be asked here because you know how to write a program. Okay, so carefully read the question and answer what is being asked. Understood? I hope you have discussed all these things. And today, like I discussed about what is that? Uart concepts. Okay, so tomorrow, probably the last class. Okay, so I'll be discussing about baud rate generation problems and then programming Uart to display some message. That's all. See, UART is used mainly for displaying certain message, whatever that should be displayed on the monitor or whatever that should be released to the channel. It will receive the packet and it will display on the monitor, or it will receive the packet and transmits to the communication channel. Okay, right? At what rate it does that and what are the requirements that we are studying with respect to UART. That's all. Okay, so can we wind up this class tomorrow? At what time you have? Anybody is taking first hour? Tomorrow? Or 10 o'clock somebody is taking? Or they have finished all the topics? 10 o'clock who is handling? If they are not taking, I'll be taking the class at 10 o'clock and when I will wind up. Who is class? Huh? Madam is finished? I
Portions
will
has
ask them.
been
Huh?
completed. Ma'am, for this test, portions has been completed, ma'am.
Okay, I will ask madam, Pushpa madam, no?
Okay.
Pushpa madam, right?
Yes, ma'am.
Okay, I'll ask her today. Like if she gives me class, I'll be taking at 10 o'clock tomorrow.
Okay,
I'll be
ma'am.
completing. Okay.
Okay, ma'am. Thank
So
you,
I'll
ma'am.
not be taking at 12:15. ML students, it's okay? Janardana?
Yes, ma'am. Yes, ma'am.
Okay, thank you. Okay, so if you don't have any other assignments tomorrow, I'll be taking the class at 10 o'clock. Let us wind up this UART, okay, and complete this the whole of interfacing with LPC 2148. Actually, there is a keyboard interface also, like we are not doing right now. So anyway, if possible, let us see after the internals. Okay, so it's only for demonstration purposes there, but you should know how actually keyboard interfacing works. Okay, but tomorrow I'll be just winding it off for, key with this Uart. Okay, so that I can explain for half an hour keyboard interface, no problem. Right? So tomorrow, like, would be the last class for, for internals. Okay, not the last class for the whole subject. Okay, so tomorrow we shall take at 10 o'clock with the permission of Pushpa madam. Right? Okay, see you all. Bye. Should I take attendance? If you say
Ma'am,
yes, I take.
class
Ah, okay, okay. Yeah, thank you all. See you tomorrow at 10 o'clock. Bye.